how do you define a circle? Well, first I need to ask you guys a question. How are these circles different? How are these circles different? There's big ones, there's small ones. What else?
They're in different quadrants.
They're in different quadrants. Oh, big words right here. Yeah, this one right here is in quadrant 1. Oh, good guess. That's in quadrant 1. This one's kind of mostly in quadrant 2 and then a little bit in quadrant 3. Okay, so they're different locations. What else? Come on, I want to hear some more academic language concerning circles.
Different diameters.
There's different diameters. Very good. The diameters are all different lengths, right? Their radiuses are all different. Very good. That's half the diameter. The circumference. Oh wow! All the words that are coming out. Oh, circumference, area, blah blah blah. Now, what if you were looking at one of these circles, and you were trying to describe to someone the circle, so they would be able to draw the exact circle? What would you have to tell them? They would have to know the radius, because if you knew the radius, you'd also know the diameter. So radius. Let's talk about the diameter. Just say they have to know the radius. So we need the radius. What else do we need?
The points on the graph.
Radius. Yes, you could tell them all the points in the circle, right? You can be like, well, this point is this, and this point is this, and this point is it, right? You can tell them all the points, or you can just tell them one other thing. There's actually only one other thing you need to tell them so that they would draw the exact same circle. The center. You need to know what the center is of the circle. These two things, the radius and the center, define a circle. The center tells you exactly where it's at in the graph, and then the radius tells you how far out the circle goes. Now, if I move the radius around, like if I put the radius right here, it'll be the same length as the radius right here, and that'll be the same length as the radius right there. Okay, the radius goes the same length all the way around, so we just need the center and the radius. And so, what can we use to define the radius? The radius is a length, right? What can we use to define a length? No. What did we just work on? The distance formula. Okay, so how would you define this circle right here? Well, what you need to do is simply define the radius. But there's something very important. You need to have the center on the radius. And so you're trying to find the distance between 2 points, the center and one of the points on the graph. So I mean, like your point could be right here. It doesn't matter. I mean, as long as you use one of the points that are on the circle, you can define the circle. So we need to do the distance of the circle, as long as one of the points is in the center. So this is how you do it. So we need an equation that has the center in it, and it defines the radius, the length of the radius. And so what we're going to do is we're going to take the center point is HK. We always say HK is our center. And then some outside point. Now remember, I said that any point on the outside is going to work. So it could be that XY, it could be this XY right here. It doesn't matter. And so in order to define this circle, we just need to find the distance between the HK and the XY. And so this is what you do. You take the X and you subtract the H and you square it. And you take the Y, you subtract the K and you square it. And that equals what? Do you guys know what it equals? The radius squared. Does that look familiar? It should look familiar because it's a squared plus b squared equals c squared. You guys remember earlier how we used the Pythagorean theorem to find the distance? Well, we're going to use the Pythagorean theorem to help us define what a circle is on a coordinate plane. So, what is our HK for this circle?
0, 0.
It is 0, 0. So we have x minus 0 squared plus y minus 0 squared equals r squared. Now, we have a special case here. We can see the graph. So, we have two ways to find the r. We can either A, plug in an xy point. Like we can go, this is 0, 1, 2, 3, 4, 5. So we can plug in 0 and -5, or we could just count the radius. I'm going to go ahead and pick a point, just because you guys are sleepers out here. There's a point right there. Oh, here's a point right here. Let's do this point. This point is something 0. What was that? 1, 2, 3, 4, 5, 6. So that's 6, 0. So let's see here. We have 6 minus 0 squared, because that's the x. I'm taking that x right there and plugging it in right there, plus the 0 minus 0. So I just took the y right there and plugged it into that y, squared equals r squared. So what is r squared? Let's see. This is going to be 6 squared plus 0 squared equals r squared. This will go away because 0 squared is nothing. And then 6 squared is 36. So what is r? R equals 6. Our radius equals 6. But the equation will look like this. We have to take the equation x minus 0 squared plus y minus 0, because it has to have the hk in there. And then we have to have the radius in there, and the radius is 6. And so the simplified version is 36. This is y squared, because the 0 doesn't do anything. And this is x squared, because the 0 doesn't do anything. This is the equation of this circle. And I just went a huge roundabout way to show you this. In an effort to try to help you understand it. Here are the two formulas once again. Here is the formula when you need to show that what hk is. And this is a special formula. Do you guys know what's special about this formula?
It's on the origin.
Yeah, this circle right here is on the origin. This is when hk equals 0.